Hello students, today we will be looking into theorems based on similar triangles. So one by one we will be taking a look at all the theorems which are required for class 10 ICSE board. It will be useful even for the CBSE boards and the state boards also. So I start with the first one called as Basic Proportionality Theorem, also known as Thayer's Theorem, named by the mathematician who gave this theorem. It is based on triangle, so it says, if a line is drawn parallel to one side of a triangle, then it divides the other two sides in the same ratio. So, I have drawn a triangle ABC and this line DE is parallel to BC. So that takes care of this part. If a line is drawn parallel to one side of a triangle. Now you can see this line DE is cutting AB and AC. So here AD is getting divided into parts. And the parts are, one is AD part, the other is DB part. Same way you have the parts here AE and AC, and the theorem says that these ratios will be equal. So let us write and see what it means. So I write here, if DE parallel to BC, so this line is parallel to this, then as a result I get here AD by BE equals to, in the same pattern, the ratio on that side, that is AE by BC. So one way of representing this is in this ratio. There are various ways by which we can write the ratio. Okay, like I can take another case here. I will write here now AD, same as this one, but in the denominator part, the ratio I will take the entire length AB. So I need to write the other side also in the same pattern. So it will be AE and then the entire side here becomes AC. So this is another way of representing this Thayer's theorem. There are more ways by which you can get the ratios. Okay, like I can take now BD. So BD by the entire length AB. So try to check out and see what I will go to write on the other side there. In the same pattern, if I go, where DB is coming is EC. So you must have recalled that it is EC by the entire part AB is same as AC. So I go to write there AC. Now, what will be the application when you do this? You apply this while doing the sums. So, everywhere there is a involvement of 4 lengths. In most cases, out of those 4 lengths, you will be provided with lengths of 3 of them. And the 4th one you have to find. So, seeing which all lengths are there and which you have to find, you can apply any of them over there. Or if there are only 2 values given for 2 lengths, you will be usually asked to write the ratio of the other side. Now, let us move to the second theorem, which is just the reverse of the first theorem which we did just now. It is the converse of Basic Proportionality Theorem. So the statement says, if a line divides 2 sides of a triangle in the same ratio. So for this theorem to be applied, this has to happen. A line should divide 2 sides of the triangle in the same ratio. Then what happens? Then the line is parallel to the third side. So if I get 2 sides of a triangle being divided in the same ratio, then that line will become parallel to the third side. Let us see in this figure ABC, I am taking here that if AD by DB is equal to AE by EC. So I am getting this ratio of AD by DB equals to AE by EC. Then I can go to write that this line DE is parallel to BC. So line DE is parallel to BC. So it's a very simple theorem. You will know that you will be required to use it if you are asked to prove two lines parallel. And how will you get the sides ratios equal? You will be provided with values of the sides over here, and you have to show that AD by DB, whatever value comes, the same value comes for AE by EC. The ratio pattern, like in the previous one, we took some other pattern. It could be same in those pattern also. Like for example, I find the ratio for AD by AB and think I get it the same if I find for AE by AC. Then the two triangles, then in that triangle you will get DE parallel to BC. Okay. Let us now see the third theorem, which is called as internal angle bisector theorem. And the statement of the theorem goes like this: the internal bisector of an angle of a triangle divides the opposite side internally in the ratio of the sides containing the angle. Try to understand the meaning of this theorem properly. So I split it up into parts. It says the internal bisector of an angle of a triangle. In this triangle ABC, AD is the angle bisector. So it means angle BAD is equal to CAD. For this theorem to be applied, we need to have this internal angle of any of the angles of a triangle. So based on this, I will write here, if AD bisects angle A. So I need to get an angle bisector first. Then what it says, divides the opposite side. Opposite to angle A is the side BC. So it will divide this opposite side in the ratio. So opposite side is going to two parts, BD and CD. So whatever ratio I get with BD and CD will be the same as the ratio of the sides containing the angle. Now, which are these sides containing the angle? I have bisected here angle A. Angle A is made by the sides AB and AC. So, AB and AC are the sides which contain the angle. So, whatever ratio I get with AB and AC, it says the same ratio will be of BD and DC. So, I go to write here then we have AB by AC, that is the ratio of the side which made up that angle A, that will be equal to the ratio of the opposite side which I am getting as BD and CD. So I will write equal to BD and CD. So how do you come now that to know that you will require this theorem? Try to see in the sum, are you provided with angle bisector? And then if the measurement of the sides are asked. So if any of these, one of these sides are asked, the remaining three will be given to you. So think now AB is given, AC is given and BD is given but CD is not provided. You can get it from here. And also it could be you are provided with AB and AC. So this side is known, this side is known and even this side BD is known. You can be asked to calculate the length of BC. So first try to get CD by applying this and then add up BD and CD to get the length of BC. Now let us take a look into the next theorem, which is based on areas and sides. So whenever we have two triangles similar, we can relate the areas with the sides of the triangle. So this theorem says the ratio of the areas of two similar triangles. So it is only based when the triangles are similar. is equal to the ratio of the squares of their corresponding sides. So if we take the same sides of the two triangles, square it and find the ratio, the theorem says the ratio will be the same as whatever is the ratio of their areas. So we can represent it mathematically in this way. So if I write here, if triangle ABC is similar to triangle TEF. So I should first get the two triangles similar. It might be given as similar, it's good. If not, we will have to prove the two triangles similar to get the ratio between the areas and the sides. So then it happens like this: area of triangle ABC by area of triangle DEF will be equal to, if I am taking of the first triangle AB, it is same with the corresponding side as DE. So I will write it AB square by DE square. And if I take the side BC, corresponding to that is EF. So it will be BC square by EF square. And if I take AC, corresponding to that is DF. So it will be AC square by DF square. So how will you get the sums here? Simplest sum in this will be involved with areas given of the two triangles, and any one of the two triangles side is given, and you will be asked to find the corresponding same side of the other triangle. Or you could be given about the ratio of the sides and asked to find the ratio of their areas. Or if it is given to you ratio of the areas, then you are asked to find the ratio of the sides. But when you apply this theorem, you need not write all the three sides ratios. See which side is to be related. According to that, you take those particular sides also. One more instruction here. When the areas are given and any one of the sides you have to find, take the square this side to get the square root. Do not find the square of one of the side which is given and complicate your calculation. Take it this side, find the square root, and then take the other number this side to solve and get the unknown side. Now we come to the next theorem, which is very much similar to the one done previously. In previous theorem, it was the involvement of the sides. Now it is the involvement of the medians. So remember now what I will tell about what are medians of a triangle. Median of a triangle is a line drawn from the vertex of a triangle joining the midpoint of the opposite side. So I am marking here this median A which is there from A vertex which is drawn as AM, and for this one the median as BM. You can notice BM is equals to CM and EN is equals to FN. It means M and N are midpoint. So AM and DN are medians. So you should remember what does median means. Okay. Now theorem representation is same as that of the sides base. So if the triangles are similar, again I repeat, you have to have triangles similar in these theorems. And then what I will get is this: area of triangle ABC by area of triangle DEF equals to the square of the first median AM square to the square of the other median DN square. And when you will get sums based on this theorem, it will be very easy sum, because it will be the involvement of the two areas and the median. So 4 things are involved, out of that 3 will be provided, you have to find the 4th one. Or if only the areas are provided, you will be asked the ratio of the medians. or if medians are provided, you will be asked the ratio of the areas. Let's move on to the next theorem. So we come to the next theorem, which will be theorem number 6, and similar to the last one, now medians get changed into altitudes. The statement entirely remains the same. The ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding altitudes. Now we should know what is altitude. From the vertex A, when I draw a perpendicular line on the opposite side, it becomes altitude. So AP is drawn perpendicular to BC, so AP is the altitude here. And in this triangle, from B I have drawn a perpendicular on the side EF, so DQ is the altitude. So if the two triangles are similar, then I will get area of triangle ABC by area of triangle DEF equals to square of this altitude AP square by the square of this altitude DQ square. The type of sum will be the same as what I explained you with the medians and the sides. Again, you find a monument of 4 things. So 3 of their values are given, you have to find the 4th one, or it could be finding the ratio of the areas with altitudes given, or the ratio of the altitudes with the areas given. The last theorem, which will be theorem number 7. Again, based on the previous 2 types of theorems only, we had already done with medians and altitude. So now coming to angle bisector. Statements remains the same. The ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding angle bisector. So in these two triangles ABC which are similar, AX is bisecting angle A, so angle BAX equals to angle CAX. Here DY is bisecting angle D, so angle EDY equals to angle FDY. Now the theorem says if the two triangles are similar, the ratio of their areas, so then area of triangle ABC by area of triangle DEF will be equal to AX square by DY square, which are the angle bisectors. So whether it is based on sides, medians, altitudes or angle bisector, whenever you write the ratio of the areas, it will be equal to the ratio of whether it is sides or altitudes or angle bisectors or medians. Same result will be there. So the type of sums which you get in all these 4 cases will nearly be the same. But a very important instruction. In the exam, whenever you are asked to find the ratio, you need to leave the answer not in fraction but in ratio. It's written as a fraction here so that easy to understand. But if the answers are written asked in ratio, you should give your answer in terms of ratio, not in fraction. Because if you write in fraction, that last marks, which is the accuracy answer marks, you will not be getting. Hope all these theorems you have understood with what I have explained. Make use of it, apply in the sums and get them correctly done. If you have liked this video, kindly subscribe and comment upon it. Thank you.